All right, today we're going to talk about permutations, but before we get started on that, let's take a look at these first two examples. This first example just asks how many ways can 5 different books be ordered on a shelf from left to right? All right, well, you know how to do this already. We can just apply the multiplication principle. We have a series of tasks we have to perform. There's actually a couple different ways we could think about this. All right, we could think about just picking up the first book and then deciding of the 5 different positions on the shelf, where do we put it? Or we can think about, okay, we're gonna fill the first position, and we could choose a book and to fill that position. So we can kind of think of it either way. I think I'll think about it the latter way. It's kind of the way I tend to think about it, but you could think about it either way, and it actually helps to be flexible in your thinking. So let's say first of all we're going to fill that first position on the shelf, the leftmost position. And I've got a pile of books that I have to put on the shelf, right? I'm going to first of all choose a book, and I have 5 books to choose from, right? So I have 5 choices for that first task, right? So I'm just going to say my first task is just I need to pick up that first book, and I have 5 books to choose from. Okay, then the next thing I'm going to do is I'm going to fill the next position to the right of that book. All right, so again, I'm going to look at my pile of books. I'm going to pick up book 2. Right, I have 4 books left in my pile, and I'm going to put it in that next position. And then I'm just going to keep going. So I'm going to fill the next position to the right, and I have now 3 books to choose from in my pile. And then book 4, I have 2 books to choose from, and then finally I'm gonna pick up book 5, and I'll have 1 book left to fill that position. So I'm just using the multiplication principle. If I just multiply the number of ways to complete each task, then I'll get the total number of ways to complete all of the tasks together. So that gives me 120 ways to arrange the 5 books on the shelf. Okay. Now I could do the same thing if I would just pick up a random book and then decide I'd have 5 different positions to put it in. If I considered each position a slot, to put the book in. So you can kind of think of it either way, but I guess I tend to think of it as, having a pile of books and choosing books from a pile. All right, so example 2 is very similar, right? Except now we have 25 books, right? So we got to go through the same process. My first, I'm going to fill the first position on the far left of my bookshelf, and I have 25 books to start with, so I have 25 choices. And then I just going to keep going. I'm going to have 24 choices for the next position, and 23 choices for the next position, and 22 choices for the next position, and oh my goodness. All right. Okay, so you see an issue here, right? I mean, I could list all those numbers out, but I don't want to. It's a lot of work. So what I want to do is introduce you to the factorial notation. This sequence of multiplying these descending numbers is a very common thing to have happen, and so mathematicians, in their infinite wisdom, have created notation in order to as a shortcut for writing out that repeated multiplication. All right, so we're going to define n factorial to be equal to n. Okay, so n is just a number. In my first example, n was 5. We had 5 books to choose from that we had to place on the shelf. In example 2, my n is 25. All right, but whatever n is, it's n factorial is just n times n minus 1 times n minus 2 times n minus 3, and so on, all the way until you get down to 3 times 2 times 1. That's all there is to it. N is a whole number. N is a whole number. All right, so no fractions. Okay. All right. So for example, oops, there we go. For example, let's just do some examples of different factorials. All right, so 1 factorial. Well, okay, that's just going to be 1. And then n minus 1 is 0, so I don't want to go below 0. So 1 factorial is just 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. 4 factorial is just what you'd expect, 4 times 3 times 2 times 1. Okay? And we could keep going. 5 factorial would be 5 times 4 times 3 times 2 times 1. All right, so there's some examples. We've already shown 5 factorial up in example 1. One other thing you should know is that 0 factorial is equal to 1. Okay, so what that's saying is that if you have 0 things, they can only be arranged one way. So that's sort of why 0 factorial is equal to 1. It seems strange, right? Because it just you would expect it to be 0, but it's not. So just remember that 0 factorial is 1. Okay, so that's important. All right, so let's go back to our example 2. Now that we know factorial notation, I can just write this as 25 factorial, right? Now, there's a way you can do factorials in your calculator. If you have a TI-84 or TI-83, I'll probably maybe record a video kind of showing you some of the things that you could do with your calculator, how you can do permutations and you can do factorials and you can do combinations on your calculator. If you're interested, it can make life a little simpler. But actually, if I put this into my calculator, it gives me a number, but it's so big that it doesn't fit on the screen. I had to calculate this value on a computer I think I went to the internet to find out what this was. So here's what I got. I'll write it all out here. All right, so that's the number I got when I went to the internet to find out what 25 factorial is. It's 15 septillion, 511 sextillion, 210 quintillion, 43, what is that, quadrillion, 330 trillion, 985 billion, 984 million, and then and that's it. So it's a big number. So about 15.5 septillion ways. Now, if you put this into your calculator, here's what you'll get. You'll get something that looks like 1.551121004, and it'll say E25. Okay. So what that means, it means it's scientific notation. It means 1.551121004 times 10 to the 25th power. So essentially you just need to take this decimal place and move it 25 places to the right in order to get the number. Okay, so you may run into that from time to time in this class where you get either a really small number or really big numbers and you get scientific notation. Some people have had that before. They've run into scientific notation before, and I find in this class that some people have not. And so if you have any questions, just let me know, because you might also run into a number where you get a negative exponent, and then you just are moving the decimal place the other way to the left. But in this case, it's a really big number, so we're going to move the decimal place to the right by 25 places. All right, well, that takes care of example 2, and I'll meet you for the next video.